Question in part B. What is the probability a personal loan belongs to a homeowner? Rewrite the question using the probability notation. This is going to be an interesting one because we see that a personal loan that belongs to a homeowner may belong to one of the two groups. It's either in default or it's not in default. So therefore, what we could do is we could rewrite the probability of H in the following way. Probability of H is the probability of D in H, or not D in H. So here we have the union of the two mutually exclusive events. These are the two mutually exclusive events, and we're considering the union of these two events. So what is the law that we apply when the events are mutually exclusive or disjoint, and we want to find the union, the probability of the union of those two events? So probability of A or B is equal to probability of A plus probability of B. And so here A and B are mutually exclusive. Or we may say disjoint. So using this law of probability, the next line or the next step is the following. Probability of D and H plus probability of not D and H. Now, we're going to work on each of these terms, but recognize that probability of not D and H is the probability we already found in part A of this problem, okay? So probability of not D and H using the multiplication law is the product of these two probabilities. Probability of not D times probability of H given not D. So once again, it's 0.9 times 0.7. In a similar way, we can also find this probability using again the multiplication law. So it's the probability of D times the conditional probability of H given D. So it's 10% chance times 20% chance. Combining the two probability values, we get a 65% chance, and that is the probability we randomly select a personal loan that belongs to a homeowner.